Let us see how we can assign ranks using different rank functions. If we have to assign ranks globally, we just need to specify order by. If we have to assign ranks within a key, then we need to specify both partition by as well as order by. By default, order by will sort the data in ascending order. We can change the order by passing DESC after order by. DESC will sort the data in descending order. We have three main functions to assign ranks: rank, dense rank, and row number. However, row number is not meant for ranking, but it serves the purpose in some cases. You will understand when we see the differences between the three in a moment. Let's load the SQL magic and then create this environment variable called as database_URL so that we can connect it to retail database to run the queries. Here is an example to assign sparse ranks using daily product revenue within each day based on revenue. Daily product revenue is a pre-aggregated table where we have data related to each and every product at daily level. You can see the query here. This way you will understand the syntax. You just have to specify rank like this. You don't need to pass arguments for typical behavior. You can just say rank like this and then over, and then partition by order date, order by revenue DESC, because we want to assign top rank to the product which is generating highest amount of revenue. That's why we have to sort the data in descending order with respect to revenue. However, we are trying to assign ranks within each date. That's why we have order date as part of the partition by. And then RNK is the alias, and you should be able to see all the three columns plus the rank. You can see that the top revenue is $5,599.72. The corresponding product ID is 1004. Rank 1 is assigned on 2013 July 25th. The next revenue generating product ID is 191 with revenue $5,099.49. You can see the rank 2 here. Similar to that, as we go down, the revenues are in descending order and ranks are assigned accordingly. If you scroll down further and if you go to the next day, 2013 July 26th, again 1004 is the product ID which is generating highest amount of revenue. However, the revenue is $10,799.46 and we got the rank 1. This is how you should be able to use rank to generate sparse ranks based upon the attributes such as revenue, as we have seen here. Here is another example to assign sparse ranks using employees data set within each department. We will also see an example with respect to dense rank. Make sure to restart kernel as you might have connected to retail database. Otherwise, the connection will not be reset. The way you can restart is by going to kernel here and then by clicking on restart kernel. It will take care of restarting the kernel. Then you have to load the SQL magic again. You have to create this database_URL environment variable. Let's preview the data of employees table. Here I'm only projecting employee ID, department ID and salary because we are interested only in those three to assign ranks. You can see that department ID 10 have only one employee with employee ID 200 and salary is 4,400. With respect to department ID 20, there are two employees, 201 and 202. Their respective salaries are 13,000 and 6,000. With respect to department ID 30, there are 6 employees. You can see the salaries here. Now let's assign ranks for each of these employees within each department by running this query. You can see the syntax is the same as we have seen earlier. There's a typo here. I just have to update this. We can run now. You can see that in department ID 10, as there is only one employee, that employee got rank 1. Within department ID 20, there are 2 employees. Employee ID 201 got rank 1 because he is making highest amount of salary within the department. If you look at department ID 30, there are 6 employees. Employee ID 114 got rank 1 because he is making highest amount of salary, and employee ID 119 got rank 6 because he is making the least amount of salary within each department. This is using rank. We have assigned sparse ranks. Here is an example with respect to dense rank. It is same as what we have seen earlier. Apart from dense rank here, everything else is same. Earlier we have used rank, now we are using dense rank. You can run this and you can see the output. For the data which is shown here, whether you use rank or dense rank, the ranks are same. However, there are differences. We will see those differences in a moment. For now, from the syntax perspective, we have understood how dense rank can be developed. That being said, here is an example for global rank based on salary. If all the salaries are unique, we can use limit with order by. But when they are not unique, we have to go with analytic functions. For almost all the practical scenarios, we have to use analytic functions. For some simple use cases where we just want to analyze the data, using order by with limit might work with respect to global ranking. But for all real world scenarios and practical scenarios, we should fall back onto the analytic functions even with global ranking. That being said, this is how the global ranking will look like using analytic functions. You don't need to have partition by with respect to global ranking. You just have to say all the attributes and then rank over sorting criteria and then provide the alias like this. So in this case, we are using both rank and dense rank as part of one query. We should be able to run this and review the results. So globally, the employee ID 100 in department 90 is paid higher, and hence he got rank 1. And then there are 2 employees within department ID 90 who got the same salary, 17,000. Both of them got the rank 2, whether it is rank or dense rank. However, this is how rank and dense rank will differ when we have same values while assigning ranks in a particular column. We will get into those details in a moment, but for now you can see that when we use rank, it skipped rank 3 because there are 2 with rank 2 and gone to 4. With the dense rank, we got 3. It did not skip any rank in between. We will again reiterate the difference in a moment. So this is how you can actually achieve global ranking either by using rank function or dense rank function leveraging the analytic functions. Let us understand the difference between rank, dense rank and row number. We can use either of the functions to generate ranks when the rank field does not have duplicates. So in this case, rank field is nothing but salary when we are talking about employees data, revenue when it comes to department product revenue data. As long as there are no duplicates in those fields, we can use either of the functions, rank or dense rank or row number. When rank field have duplicates, then row number should not be used as it generates unique number for each record within the partition. Every time we run, we might see different row number for such records. Rank will skip the ranks in between if multiple people get the same rank, while dense rank continue with the next number. So that's the major difference between rank and dense rank. In most of the cases, we use dense ranks because the use cases will be get me top 10 salaried employees, which means there might be 10 top salaries, but number of employees might be more than 10. Another use case can be get me top 10 revenue generating products, which means there can be top 10 revenues. However, there can be more than 10 products matching the criteria. In those use cases, we have to use dense rank. Rank will not suffice. And most of the use cases with respect to ranking will be similar to that. Get me top 10 salaried employees or get me top 10 revenue generating products. In those cases, we have to use functions like dense rank. You have to really understand the meaning of the requirement and then you have to decide which function should be used. Now let me restart the kernel to ensure that I can connect it to HR database without any issues. Then let me load this SQL magic. Let me create database underscore URL environment variable. Let me run this query which have all the 3 functions, rank, dense rank and row number. If you look at the ranks with respect to department ID 20, both the records got the same ranks whether you use rank, dense rank or row number because these 2 are unique. Even with respect to department ID 30, we got rank, dense rank and row number same because all of them are unique. If you look at department ID 50, after rank 10, you see the differences because there are 2 employees who get same amount of salary, which is nothing but $3,600. The employee IDs are nothing but 137 and 189. In this case, both 137 and 189 got the same rank, whether you use rank or dense rank. But with respect to row number, it is not. And hence we cannot use row number when we have duplicate values in the field based on which we are trying to compute the ranks. You can see that in this run, 137 got row number 11, 189 got row number 12. In the next run, it can swap. It is not guaranteed that same row number will be assigned in these scenarios. Now if you scroll down further, again with respect to these 2 records, rank got 15 because it skipped the 12 here, whereas dense rank got 14. When it comes to row number, it got 15 and 16. Now when it comes to difference between rank and dense rank, with respect to rank, as there are 2 people getting same rank, it has skipped rank 12. There is 1 rank which is duplicate and hence 1 number is skipped. With respect to dense rank, it did not skip. After 11, it assigned rank 12 for employee ID 141. Now you can again go to these 2 records. Both of them got the same rank. However, with respect to rank 16 is skipped. With respect to dense rank, the next rank, which is 15, assigned to the employee. So based upon the number of duplicates, the number of ranks can be skipped using rank. With a dense rank, that is not the case. Let me actually use 50 here and run it. Now if you scroll down to rank 17, you can see that 4 people got the same rank, which means there are 3 duplicates and hence 3 ranks are skipped. Next rank is 21. Whereas with dense rank, the next rank is 16. So that is the major difference between rank and dense rank. unless and until you use dense rank in the use cases like get me top 10 salaried employees or top 10 revenue generating products, you will not be able to get all the top 10 revenue generating products or top 10 salaried employees. For that reason, we have to use dense rank only. We should not be using rank in those kind of scenarios. So this is about rank, dense rank, and row number difference. When it comes to row number, as I mentioned to you earlier, in each run, it might assign a different row number. However, if you want to make sure that every run you assign the same row number, what you can do is you can actually say row number over partition by department ID, order by salary, DESC, and then you can specify some unique field such as employee ID, and then you will be able to assign same row number in each and every run. However, still it will not solve the purpose with respect to ranking, but in some cases we might want to assign some unique number for each and every record based on certain criteria. In those scenarios, we can use row number with this approach. Especially we can add unique key like this to make sure that the same record is assigned with the same row number in each and every run. You can run this and it will work without any issues. Wherever there are contentions, it will actually fall back onto the unique ID such as employee ID to assign the same row number in each and every run. Now here is another example with respect to all three functions. Make sure to restart the kernel as you might have connected to HR database, because in this case we are trying to connect to retail database and run against daily product revenue table. So let me restart the kernel. Let me load SQL magic here. Let me create this database underscore URL environment variable and let me run this. You should be able to see the output here. Almost all the ranks are assigned same, whether you use rank or dense rank or row number. You can see only here you can see the difference. On 2013 July 25th, product ID 924 and 926 got the same revenue. With respect to rank, both of them got 22. With respect to dense rank, both of them got 22. With respect to row number, 924 got 22 and 926 got 23. When it comes to rank, it skipped one rank after that. With respect to dense rank, it did not skip. So this is the difference between rank and dense rank. Make sure you understand this by running these two examples and going through the data. This is how we should be able to leverage rank or dense rank or row number to assign ranks based upon the certain criteria, either globally or within each partition.